All right, so we're going to begin by getting our unit cover sheet in our journal. So you should be going to the very next blank page in your journal. I'm going to go ahead and label this Unit 7 cover sheet. And you're going to go ahead and take your cover sheet, just like we've done in the past, and get that into your journal. I'm not going to use the time in this video to show you getting that in place, but if you would like, go ahead and pause the video really quickly just to make sure that everyone gets their Unit 7 cover sheet in their journal. Okay? All right, so we're going to go ahead and look at our very next section. We are, let me zoom in just a tad. We are going to start with our title and EQ like we do all of our notes. So this is going to be 2/13/2019. And we're going to look at modeling and solving one-step equations. So we're going to look at how do we model and solve one-step equations. Now you should be writing as you hear it and as you see it on the screen. That way you are prepared with your notes. Okay. Today's essential question is going to be, how do we model and solve? Actually, I'm going to change that. How do we model, solve, and represent solutions of one step, one variable equations. Now I have written a little bigger. Okay, let's make sure that you see that. How do we model, solve, and represent solutions of one step, one variable equations? All right, let's go ahead and begin with one of our vocabulary terms that we need to define because we're going to be using this pretty regularly. So in my sidebar here, I'm going to go ahead and ask the question, what are inverse operations? Okay, what are inverse operations? And so you probably have heard that term before. Okay, another way to think of inverse, right? We're looking possibly for, not possibly, but we're looking for opposite operations. That might help you identify what inverse operations are. Okay, and so these are operations that undo each other. Essentially, they're opposite operations. So we know we have addition. So the inverse of that would be subtraction. And we have multiplication. And the inverse of that would be division. Okay. So these are our inverse operations. So let's go ahead and look at the steps involved in solving one step, one variable equations. So I'm going to go ahead and have a sidebar question as well. How do we solve, right? And I can replace solve with how do we model, how do we represent, All of those terms can be replaced here, so you could interchange that word solve, and we can look at how do we model them, how do we represent them. So how do we solve one step, one variable equations? Now pre-AP, our pre-AP groups, you are going to be learning how to do two-step equations, but we'll focus on that next week. For right now, we just need to get the foundation for everyone, which is modeling, solving, and representing one-step, one-variable equations. Okay. So before we get started, you have to recognize the goal in this whole process, and if we kind of keep this in mind, then it's going to help make the process a lot easier. Our goal is to isolate the variable, right? Which means, okay, think about the word isolate and what that means, right? Most of you are probably thinking, oh yeah, that means something like to be by yourself or to get it by itself. That's exactly what we're going to do here to solve these. So we're going to get the variable by itself. Okay, so I'm going to go over 3 basic steps. The first one is we're going to determine what operation is being performed. So when you look at the problem, you need to determine what operation is being performed. Okay. Then we need to apply the inverse operation to both sides of the equation. Finally, we've been practicing this, we are going to check our solution using substitution. Okay, sorry, you can't even see that. Okay, so there it is. Step 1, again, we're going to determine what operation is being performed. Step 2, we're going to apply inverse operations to both sides of the equation. And then step 3, we're going to go ahead and check the solution using substitution. Okay. All right, and so because this particular lesson is going to be looking at 3 different parts, modeling and solving, right, and then checking using substitution, we need to first begin with kind of our algebra tiles, and we need to know what these algebra tiles represent and what they look like. So I am going to grab some different colors here really quickly. Okay, so when you're thinking in terms of algebra tiles, they each have their own color and their own value. So let's go ahead and start here by identifying what are these algebra tiles that we're going to be using and what their values mean. So here's just a quick question. what do the algebra tiles represent? And this is really looking at their value. Okay, what do the algebra tiles represent? Okay, so I'm going to start by showing you, I'm going to just draw the rods out and then we will color them. They are typically color coded, and obviously when we're drawing them, right, they may be in black and white, so we also need to know how to recognize those when they're in black and white. But for today, I am going to use color coding, and so you are going to want to grab some as well. So our first tile that represents a positive X, right, is going to be green. This is for our unknown, right? If we have a positive unknown value, it is green. Okay. Now when we have our small square tile, so we have our large bar, this is our algebra tile bar, it's going to be the X, right? It's unknown. Let's include that there. All right. And then we have a positive 1. Okay. So this is going to be yellow. All right. Then you're going to have our negative X value, which again can still be, or will still be, unknown. It's going to be a negative X, and then we have a negative 1. And both of these are negative X, and my red is not working, and my negative 1 are both going to be red. Okay, so that's sufficient enough for you to kind of get the idea here. Negative X and negative 1. All right, so I'm going to pause it here. And we're going to go ahead and grab the foldable, which is the other paper that you were given. So you should have all this, and we're going to use those. Then I'm going to take this. Guys, and so you should have a paper that looks just like mine. Okay. And it has an equation, algebra tile models, how we're going to solve it algebraically, and then how we're going to check it using our solution. Okay, so we're just going to walk through a couple of these, and then you're going to practice doing some as well. So for the purposes of this, I'm not going to use the colored tiles. I am, however, going to be using pluses and minuses, and then those bars we will shade as well, or we'll label them with a positive or negative as we need it. Okay, so I'm still going to use two different colors because I do want you to see the process. I'm going to start with my first one, y'all. So for today, we are just going to focus on modeling. Okay, so we're just going to focus on this particular area here using our models. And then tomorrow we'll come back and connect it using the algebraic equation process, and we'll use substitution to check it. Okay, so let's go ahead and start here. First off, we have a G. Notice that we're using a variable, and it could be any variable. So the G would represent like our X tile. Okay, so I'm going to start with that. This is unknown. It is positive, so I'm going to leave it alone. Right? If it was a negative, I'm probably going to shade that just so you can see the difference between the two. Okay, and we're adding 5 positives here. Okay, so I'm just going to use, instead of drawing 5 little squares, I'm going to use 5 little positive symbols. So right now we have on the left side of my equal sign, we have our unknown plus 5 positives. Okay, now I'm going to use a full bar here. This is to split it, and just really quick I'm going to write on here, and I'm only going to do that with my first one. This is my equal sign. Okay, so I want you to know that when I draw this bold bar, that is separating my equation for what is on the left-hand side of the equal sign and what is on the right. Okay, so in this case, I have 11 positives. So we're going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So now I have 11 positives. Okay, so here's the model that I have. Now, according to our steps, we need to determine what operation is being performed, and in this case, we are adding. Okay. The second step said to apply the inverse operation. So what would be the opposite of addition there? Right? And you should have said subtraction. So when we're subtracting, when we model that, that means I need to do the opposite of what we have here. Okay? And so remember, the goal is to isolate the variable. I want this g to be by itself, and the only way I can get rid of positives here, right, is by subtracting them. And to do it in a model, that means I'm going to have to create some zero pairs. So I just added 5 negatives to the left of my equal sign. And whatever I do to one side of the equation, I need to do to the other. So I'm also going to add 5 negatives here. Okay. And I'm going to switch my color one more time. So purple may not have been the best choice because it kind of blends there. Let's see if I do this. Okay. What do we remember about zero pairs? What do zero pairs do? They cancel each other out. So these all go away. Now I could loop them the whole group since I have the pluses and minuses, but I do want you to see what is exactly happening here. So this 1, 2, 3, 4, 5. Notice we've made 5 zero pairs. And now whatever we have left, because on this side of my equation, on the left-hand side I have a g, which is our unknown. And on the right hand of the equation I have 1, 2, 3, 4, 5, 6 positives. So in this case, g equals 6. Okay. Let's look at our next problem. We have 17 equals h minus 11. So I'm going to start with 17 positives this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So I have 17 positives on the left side. I am going to go ahead and give a bold bar to represent my equal sign. And on the right hand side, we have h minus 11. Okay? And so if you remember this, when we have a minus, right, I really want to focus on turning these all to addition problems. So we're going to rewrite this, which means h, and when you have that minus, we're going to add the opposite. Okay? And for the modeling purposes, that is really what we want to do. We want to change that problem to an addition problem, and then we'll go from there. So in this case, I'm adding 11 negatives on the right-hand side. So we have an h, which is our unknown. It is positive, so I'm going to leave it there. That's an extremely large bar, but you get the idea. And then 11 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now, we have added 11 negatives here, right? I changed that to an addition, and I added 11 negatives. And so the opposite of adding 11 negatives would be to add 11 positives, okay? And so we're going to add 11 positives to both sides. Okay? And I'm also going to do, whatever I do to one side of the equation, I have to do to the other. Now I'm going to have to squeeze these in here because I wrote a lot bigger. So let's go with 1, 2, 3, 4, 5, 6, 7, 8. Let's see, I'm going to squeeze them in 8, 9, 10, and 11. Okay. So you can see the second step is in red there. And then we'll go ahead and show on the right-hand side, what do we have going on here? We have created 0 pairs. We have 11 of them. And these are all going to cancel out. Right? And again, I could have looped them all together. Just want to make sure we understand exactly what is happening. And then we have H on the right-hand side and our equal. So what do we have here on the left? We have 5, 10, 15, 20, 25, 26, 27, 28 positives. So in this case, H is going to equal 28. Okay. Now let's go ahead and jump down. I'm going to jump down to the third one. To the fourth one, where it's 0 equals x plus 7, because this is going to look different. And I want to make sure that we understand what to do when we have a 0 on one side of our equal sign. Okay. So I'm just going to split this down the middle again, kind of jumping ahead for us here. On the left-hand side, we're going to have 0. So this is going to stay blank. Do not put something there. Don't try to force anything there. It's a 0. Right? And we have an x. And we have 7 positives. 1, 2, 3, 4, 5, 6, 7. Okay. So looking at that model, here we have 7 positives there with our x variable. We want to get the x by itself, so we need to do the opposite or use the inverse operation here. Since those are pluses, I am going to be using minuses, right? So we're going to add those negatives or those minuses in here. I kind of think since those are positives, we're adding those negatives. And whatever I do to one side, I must do to the other. And so in this case, I need to go ahead and add 7 negatives on the left-hand side of our equal sign. And then if we look closely here, I'm going to group them all together. We have created 7 0 pairs, and these are all going to cancel out. And we are left with x equals negative 7. Okay, so what I'd like you to do is I want you to go ahead and try. You have 3 examples here that you're going to work on. And then I'm going to give you a exit ticket that you will work on. I'm actually going to go ahead and have 2 of them here. That way, in case you get done sooner, then you can go ahead and solve both of them. So this paper is going to go in our journal, right? So I'm just going to fold it in half. Let me zoom out so you can see where I want you to place it. We're going to fold it in half. Okay. I'm going to come back to my journal where we just took our notes, and it's going to go on the left-hand side. So we have our notes that we just did on the right. And I'm going to glue this in here so that it is on my right-hand side. Okay, so it'll open out this direction. Y'all got it? Okay, so you're going to go ahead and do that. And then I'm going to give you 2 problems here that I want you to model. So really quick, let me glue this myself. And the 2 problems, right? So your first task is to complete the remaining problems here. Okay, so you're going to do the 3rd one, the 5th and 6th one, okay? And then you're going to go ahead and go to this exit. And I'll just actually go ahead with 1 that I want you to go ahead and model and solve. Okay, just like we just went through with the video. Okay, so I want you to use a model and solve this. Okay, using those algebra tiles. And it's going to be n plus 3 equals 10. Okay, So I'll give you that one. The exit question on your exit ticket requires you, it's asking you to solve it algebraically, but you can actually solve that one using the model as well, and then we'll come back and solve it algebraically tomorrow. Okay, so go ahead and give this a try. Make sure that you are showing all of your work exactly how it was modeled to you, right? And then we will continue where we left off tomorrow. All right, guys.